Hey guys, Miss Sims here. I've got a video for us today about solving rational inequalities. Solving rational inequalities. So very similar to equalities, a little bit different. We are definitely going to be using some algebra and graphing with this method. So I've got us an example and we're going to kind of walk through it. And this is the handout that I've made for you so you can follow along in your handout. And then at the end, I'll do a couple more examples. So the first off we're going to do is we're going to find the restrictions. So it's the same restrictions that we've been doing. So we simply just go to the denominator, x minus 1, we set it equal to 0, and x will equal 1. And then we take the second denominator, x, set it equal to 0. So there's our two restrictions. We can't use -1, and we cannot use 0. Okay, so restrictions are still very important. Remember, they're essentially kind of the vertical asymptotes of the graph. They could be holes, but most of the time in solving, they typically are vertical asymptotes. All right, so the next thing that we're going to do in our step of solving inequalities is we are going to pretend that we just have an equal sign. Okay, we're not going to deal with the inequality. The last thing I'm going to do is really deal with the inequality. So I'm going to solve this problem just like it has an equal sign in it. So just like that, from the last part of our lesson, we know that we've got the restrictions. We do the least common denominator, which will be x times x minus 1. So we're going to multiply every term by x times x minus 1. So I'm going to move this to the negative to be with a 6. So multiply by x times x minus 1. And then even the constant, x times x minus 1. So like before, we'll cross out x minus 1. So I'll have 6x. And then I've got the x's canceled. So I have -6 times x minus 1. And then over here, I just have x times x minus 1. So work on my algebra right there, distributing that -6. So I have 6x minus 6x plus 6. Over here, I have x squared minus x because I distributed the x to those two terms. So those will cancel. They're like terms. So I have 6 equals x squared minus x. Well, like we said in class, if it's quadratic, we need to equal 0. So I'm going to subtract 6 over, and I'll write right here. So now I have x squared minus x minus 6 equals 0. Then that does factor. X minus 3, x plus 2 equals 0. So I get x equals 3 and x equals -2. So these are the solutions. So hopefully that first two steps are very familiar. So now here comes the inequality part, okay? So again, if you'll follow along on the handout, I'm going to kind of talk you through. So the first thing we're going to do, it says to create an x-axis number line. Put all the solutions and restrictions on the number line. So if you'll notice, I've already made the number line right here. Let's see if you can see a little better. So I've got -infinity and infinity. We got a solution of -2. I'm going to mark those with z's for zeros. I had a solution of +3. I marked that with a z for a 0. And then the two places that were undefined, 0 and 1, I put 0, 1, and I put u's for undefined. The z's and the u's are mostly important for the reason that when it comes down to writing intervals, I have to use brackets and parentheses. Now I know, like, if it's a z, it can have a bracket if I need it. But if it's a u, it will never have a bracket because I'll never be able to include those. So that number line should be pretty easy to make. You're just going to stick them on. It is a number line, so make sure you're going from low to high. So now we're coming to the part where we need our calculator. Okay, so what I need to do with my calculator is I need to take my problem, which was 6 over x minus 1 minus 6 over x equal 1, and I need to put this into my calculator. All right. Now, when we're using our calculator, we want all equations must equal 0. All right, so I need to be equaling 0 because for greater than and less than, if everything's equal to 0, well, 0 is the x-axis. So if I equal it to 0, then I want to look for things to be positive. It's simply above the x-axis versus below. Now, so I want to write this problem now as 6 over x minus 1, minus 6 over x minus 1 is equal to 0. Now, all my people with my 84 calculator, you have it pretty easy to type this in because you can use your up and down fractions right there and there, and you don't have to worry about all your parentheses. But if you have my TI-83, you have to be really careful about your parentheses. So if I want to type this in my 83, I'm going to say parenthesis 6, parenthesis, divide, parenthesis, x minus 1, minus parenthesis 6, parenthesis, divide, parenthesis, x, minus 1. So remember that with that TI-83, you have to put all those parentheses or it's not going to give you the correct answer. So as I come in here, you're going to see me type it in that way. 6 divided by parenthesis x minus 1, then minus parenthesis 6 divided by parenthesis x, close the parenthesis, and then minus 1 because it was the only thing on the other side. So now as I hit graph, it is going to draw my curve, and you can see that I definitely have some pieces that are below. That piece is above the x-axis. This piece is above, and there's something happening in the middle here, but I'm not sure what it is. And so the easiest way for me to check would be to press trace and maybe a number that is in the middle, like 1. And I can see, oh, 1 was a bad choice. That was undefined. It was undefined at 1 and 0. So maybe I type in 0.5. And I see that the graph is negative. So it's way down there. So if I want to adjust that window to see my values, I can come down here and make my min. Maybe it was negative 25. And now as I hit graph, maybe I'll see that little negative piece there in the middle. So it's not as well to see it because I didn't go quite low enough because negative 25 was that exact value. So maybe I make it, I don't know, negative 40. I'm just trying to get so you can see that that graph in between those two asymptotes were definitely a negative. So I have this piece that's below the x-axis. This whole segment's below. We're above the x-axis right there, and definitely below the x-axis right there. All right, so let's go back to the notes now and look at the next part I have down here. Okay, so I kind of talk about this graph a little bit better in more detail on your handout. So it tells you that if the graph is above the x-axis, that's my positive inequalities. All right, and so you see where I've drawn the picture right here, and I've marked on the graph where it's definitely above the x-axis. And if it's negative right there, then I want below. So I've marked on the picture right there where it's below. So you can see that little piece right there. And then I've put there, this was, remember, at 0 and 1 were the two asymptotes. And then here were the two solutions that I found. Okay, so that's how I look at a graph when I'm comparing it to 0. But notice the comparisons are always to 0. So that means all the terms need to be on one side of your equation. All right, so we're going to go on here to page 3 now that we've looked at the picture. And in page 3, you can see that I have marked the axis now as above versus below, meaning below was negative, above was positive. So I'm going to kind of flip back and forth. Let's take this interval from -2 to 0. And I've marked it as positive. So let's look at my picture here. From -2 to 0, it is definitely above. From 1 to 3, it's definitely above. So those two should be marked positive. The other 3 intervals should be negative because they are below the axis. So you'll notice negative, negative, negative. All right, so that's how I mark my interval. So remember that these came from the zeros, these came from the undefined. When I say it's negative, I mean the graph is below the x-axis. All right, so then I come down to like, well, how do I write my answer out? Well, it comes back to the inequality in the problem. So if it's equals to, notice the equals to, we can use square brackets. If it's not equal to, we can use parentheses. And for undefined, we can only use parentheses. So I'll be honest, I like to go back to my number line. And actually, you know what? I'm going all the way back to page 1. And we're going to look at that inequality. So that is a greater than, right? So that means I want positive. I always write it on my problem when I start. So looking at this right here, I have a greater than symbol. So I'm going back to my number line, and I'm going to write down that we had our symbol was greater than and equal to. So the first thing I'm going to do is I'm going to come in my z's and I'm going to put square brackets around them. U's get parentheses. Z's can have square brackets because I have the equal to symbol. Now, that points to the right. So to the right is positive numbers. So I want all the positives. So I want this interval right here. And I want this interval right here. Okay, so I'm going to use a square bracket around the -2 all the way to 0, but that is a parenthesis. I'll say union. And then we said 1 to 3. Square bracket because, again, the equal to. So this will be my solution to my problem. All right, so that's just one example. I am going to work a couple more with you. They're going to come off of your homework sheet. I'm going to look at 1 and 2 with you. So please pay attention to the next couple of videos to see this in a little more detail where I don't have stuff already pre-printed for us.